Guys, so in this video I'm going to explain you about JVM architecture. Okay, so first I will tell you how to run Java program via terminal. So first, Java compiler compile the code into .class file. Then that .class file will be created and JVM pick up the .class file and run. So first I will tell you the how to run through the terminal and how that .class file is created. So first go to the Sublime, just create one class that is test. Then we will write one method that is public void public static void main. In that we will write here string, array and args, and inside that we will write system dot out dot print ln. Inside we will write hello world. Okay, we will public static void main. Okay, perfect, there is no compilation error. So we'll save it and we will write this test dot java. Okay, and we will try to run it via terminal. So first we will check here. So here is our test dot class. So we'll run java c dot test dot java. There is something error, so that we have made a printing spelling mistake, so we'll correct it. So after that again we will try the same process. It get compiled and you can see in desktop, you can see here is desktop. So this test dot class file is created because when it compiled, I have already told you that when it compiled, dot class file is created. And when we use java test, then this hello world get executed. Okay, so in this way, then after this compilation, dot class file is created and JVM pick up the dot class file and run. After the JVM pick the dot class file, that after that whatever the process will execute, that I will tell you. So JVM language classes. So first is it will go to the class loader, then method area, heap, JVM language stack, PC register, native method stack, execution engine, native method interface, native method libraries. This all will explain you in this video. So first is class loader. Okay, so class loader is responsible for three activities. The first is loading, linking and initializing classes. Okay, don't worry, I will explain you these three with real-time example. So why do we need the class loader? Okay, before executing any program, the JVM need to load the required classes file into memory. Okay, link them to ensure all the dependencies are resolved and initialize them so they are ready for execution. So I will explain you. So first, the class loader automates the process of loading classes file dynamically when needed. So one by one I will explain the loading, linking and initializing. So steps in class loading. So first is loading. So loading what happened? The class loader read the .class file, that is bytecode, and generate the binary data and save some basic information in a method area. So what information will be saved? So the information is like fully qualified name of the loaded class and its immediate parent class, that is inheritance. Whether the .class file is related to class or interface or enum, the modifier variable and method information, etc. So this all information are stored in the method area, and it's create the class object in a method area of JVM memory. Okay, so this is the working of linkage, loading. So second one is linkage. So linkage is also having a three processes. The first is verification. And so verification means ensure the bytecode is valid and adheres to the JVM specification. So verification, what he did, ensuring the correctness of .java file and verify the format. If the format is incorrect, it will throw this exception java.lang verify error. Okay, then second one is preparation. So allocate the memory for static variable and initialize them with the default value. We already know that static variable. So this preparation, what he did, allocate the memory for static variable and initialize them with the default value. And third one is resolution. So convert the symbolic reference, example method or class name, and to direct the memory address. So don't worry, I will explain this you with a real-time example. So I will tell you with analogy. So first is analogy. You are finding the contact in your phone book. So imagine you want to call your friend John. Okay, and here is how the resolution process work. The first is symbolic reference. The name is John. You know your friend name is John. Okay, so this is like a symbolic reference in Java. Example, the method that is add or class. So looking for the number, that is resolution. So to actual call the John, you need his phone number, correct? You look for the John name in your phone book or contact. Once you find the name, you see the phone number. In Java, this step is like resolving the symbolic reference to the memory address where the method and class resides. So third one, dialing the number and execution. Now you use the phone number and make the call. Similarly, the Java uses the resolve the memory address to execute the method or class, access the class. So don't worry, I will explain you via code. So this is so this is the addition. Okay, so this is the addition class. So if you, so resolution, what we did, so if you want to call this method from the main, what we will do, we will give the add, we will give the address of this add. So in this add there is a method that is add. So while executing what you are saying, we are directly giving the address of this add method. So addition.add, so that is a symbolic to execute this method. Okay, so that is the purpose of resolution. Just address the method or give the direction of the that method to execute. Then third one is initialization. Execute the static block. Okay, execute the static block and assign the explicit static variable value. So what in preparation happening, the allocate the memory static variable, initialize them with a default value. Here static variable are get initialized, and here we are directly assign the value to the static variable. So this is the class loader, and there are three types of class loader. Java provides a multiple type of class loader, that is bootstrap class loader, extension class loader, and third one is application class loader. Okay, so bootstrap class loader is a parent, extension class loader is a child of bootstrap class loader, and application class loader is a child of extension class loader, and this is a parent for both. Okay, so first we will go through the bootstrap class loader. So what bootstrap class loader do? Load the core Java classes. For example, classes from java.lang, java.util package, and implemented in a native code, and is the parent for all the other class loader. So don't worry, I will explain you via code. So this is a bootstrap. Okay, so here, so these three class loader will run according to the requirements. This class loader will execute dynamically according to whatever we have written the code. For example, we have written this code. This is string that hello world, and here what we have written system.out.println. But bootstrap class loader load the java.string and java.system. Okay, because we are using this system and this string, so that's why this bootstrap class loader will invoke and find the class and load it. Okay, and extension class loader, this is a child, so load the classes from the extension directory. Example, this is load the classes from java home lib extension. It is responsible for loading the extension libraries. So extension library means that, so if you are using this library, these are the extension libraries. If you are using this library in your code, in that case only this extension class loader load the web security and custom encryptor class according to the code. So this class extension class loader execute. And third one is application class loader. So load the classes from the application path. Example, class from your object or a jar. Class from object or jar. It is used most of the Java application. So here, so what we are saying, that load the classes from the application from the class path. Classes from your project or jar file, means it will load the classes, that is this class or this class or the classes that is present inside this library. So this application class loader will look for this type of class. Okay, so I will explain you this part. So if your code uses a core Java classes like java.lang.string or java.util.list, the bootstrap class loader will handle them and the other class loader will not get invoked. Okay, it is saying that in your code, if you're not using this type of uh, classes in your program, then only this class will bootstrap will handle them. This class will not execute, these two class will not invoke. Okay, then second one is saying if your code uses the extension library placed in a lib.extension directory, then extension class loader will take over for those specific classes. The same thing I have explained you in this example. If you are using these classes in your code, then this extension library get invoked. And if your code uses the application specific classes, the class you wrote or third party libraries on your class path, the application class loader will handle those. Means application class loader will handle this type of custom class, that is this type of class or the whatever the class inside this library, third party library. Okay. After that, okay, this part I have explained you in the code only. So here is a delegation hierarchy. So first, when you try to run your program, the bootstrap class get load. It will search for the class. If you don't find any class that you are using in your code, then it will delegate task to the extension class loader. Again, you will find the classes present inside your code. If you are using this class, if the extension class loader don't get that class, then it will delegate the class to the application class loader. Okay, then it will get the class. So this is the delegation hierarchy. Now fourth one is JVM memory. So in JVM memory, they are having method area, heap area, stack area, PC register, native method stack. So in method area, the static block, static variable, reference variable, and in object data, the heap area, they are having instance variable. So in method area, the method area is a logical part of JVM where the class level data and the metadata are stored. It is shared among all the threads in JVM. So it is not a thread safe because it is shareable to all the threads in JVM. Okay, I will explain you code. So this is the method area. So this is the class. So there is a static variable, there is a instance variable, and this is a class. So when your class example is loaded, its metadata, example static variable, display method bytecode, this method goes into the method area, and the actual instance variable will allocate in the heap memory when object is example is created. Okay, after that heap area. So information of all object is stored one heap area per JVM. Shared resource, the heap area is accessible to all the thread, making it a shared memory space for entire application. Every object created using the new keyword is stored in a heap. Instance variable of object are also stored there and managed by the garbage collector. So JVM automatically reclaim the memory from objects that are no longer in use, reducing the risk of memory leak. So this is a heap memory. So and that then there is a stack memory. So stack memory. So each thread has its own independent stack memory, and no stack is shared among the thread. So this is the thread shape. So the follows the last in first out structure. When method call, then their data are pushed, that is added to the stack. When invoke and popped or remove when the method end. Stack memory is faster to access the the stack memory is faster to access compared to the heap, as it does not involve a garbage collector. Memory is allocated for the method when it is called and disallocated when method is execution is ended. Each thread stack has fixed size, and exceed this limit result in a stack overflow error. Not share resource and thread safe. PC register. So PC register is like a stack. So here is no example of stack area. So PC register. So PC register is nothing but the store the address of current execution instruction of the thread. Each thread have the separate PC register tracking the instruction execution. The PC register store the address of the next instruction that thread will execute. Don't worry, I will explain you via code. So this is the PC register. So here is when the PC register workflow, the PC register points to the when you run this code, the PC register point to the line 1. Okay, then execution jump to line 3 in add method. From this it will jump to this add method, then again it will jump to this line 1, then again it will go to read this system.out.println and print this result. Okay, so PC register is nothing but the read the instruction whatever we have written the code in a sequential form. So that is the PC register. Then there is a native method stack. So native method information. So native method stack. So next one is native method stack. Okay. So native method stack is nothing but the store the native method information. They have written code in a C or C++ and integrated this in Java code. Separate native stack for every thread. So it is nothing but to store the native method information and which are written in a C or C++ and integrated in a Java code. Okay. So the native method stack is a specific memory area in the Java virtual machine used to manage the method call which were written in a C or C++. And last one is execution engine. So here is execution engine. So execution engine is a component of Java virtual machine responsible for executing the bytecode instruction from .java.class file. It translates this bytecode into machine code and execute them. The first it's come to picture, that is interpreter, just-in-time compiler and the garbage collector. There are three factors to execute execution engine. So interpreter. Interpreter. So read and execute the bytecode line by line. So it will read the code, it will interpret the code line by line. First it will interpret this one, then this one, and likewise. And fastest there is pros that faster startup time because no compilation is required. Cause slower execution since each line of bytecode is interpreted at runtime. Pick up the bytecode line by line and execute it. Disadvantages is if there is a multiple method called 1000 times, so the interpreter will call this 1000 times, means interpreter will interpret that method 1000 times, which is not efficient. So to overcome this, so that JIT comes in a picture, so that JIT compiler comes into the picture to increase the efficiency, that convert the bytecode into a native machine code during runtime, and the machine code is stored in a cache, so the subsequent call to the same methods are faster. So what he will do, suppose this method we call 1000 times, so interpret this method 1000 times, so this is not efficient. So just in time compiler what it did, so it will compile this code into native code and keep this method into the cache, so whenever it required, it will directly, instead of interpreting, the JIT compiler directly give to this method from cache to the interpreter. Okay, so just in time compiler, so convert the bytecode into native machine code during runtime. I have already told you. So machine code is stored in a cache, so the subsequent call to the same methods are faster. Just-in-time compiler optimize the frequently used method and loop the hotspot to improve the performance. Example optimization: inline function expansion, removing the redundant code and optimize the loop. And third one is garbage collector. Although it's not a direct part of the execution engine, the garbage collector manages the memory by deallocating the unused object, freeing the space for the new one. Execution engine collaborate with the garbage collector to ensure the efficient memory management. Okay, so this is a real-time example. So what it did, step by step execution. So interpreter start the execution, the main method is loaded and the executed line by line by interpreter. Okay, when this add.ab is called, means when this method get called, the interpreter process the bytecode for the add method. Interpreter process the bytecode for the add method. It will start process for this add method. But just-in-time compiler comes into the play. If the add method is called frequently, then just-in-time compiler mark as a hotspot, and the method is compiled into the native machine code and cached. This add method, just-in-time compiler, it will add it in a cached. So for frequent call to add, the cache native machine code is executed directly. By passing the interpretation, this makes the execution faster. Then fourth one is garbage collection. After the main method is completed, unused object like local variable and garbage get collected. Then second last is that is Java native interface. So this is a Java native interface. So Java native interface is nothing but the interface is a Java native is nothing but the Java native interface is a framework that allows Java program to interact with the native application or library written in a C or C++. It will provide the platform to interact with native code, that is C or C++, using the Java code. It provides the way for Java code to running in JVM to call the native method and native application to invoke in Java method. So via Java method we can invoke the C or C++ method, that is native code. And this is last one is native method libraries. So native method libraries are collections of a compiled native code written in a language like C or C++ that can be loaded and executed by Java application through a Java native interface. So these are nothing but the compiled libraries which are written in a C++ and which is loaded and executed by Java application through Java native interface. I have already told you that because of this interface we can interact with the native code. So this is, so let's summarize the thing. So ClassLoader. So in ClassLoader what we have seen is responsible for three activities: loading, linking and initializing. Okay, so loading, in the loading we are ClassLoader is read the .class file and generate binary and save some information into the method area. Then linking, which is verifying, preparing and resolution. And this is initializing. It will initialize the static variable and value. And the ClassLoader has three types, that is bootstrap ClassLoader, extension ClassLoader and application ClassLoader. Okay, and next one is JVM stack. So in JVM stack they are having a method area, the method area is method area, then heap area, then stack area, and then there is a PC register, in which in PC register it will execute, it will follow the instruction whatever your code written. Then native method stack. So in native method stack what you learn that store the native method information which is written in a C or C++. Then next one is execution engine, and which is responsible for interpreter, just-in-time compiler and garbage collector. And last one is Java native interface. It is nothing but the interface which interact with the native code via Java code. And native method library, this is nothing but the libraries, compiled libraries of C or C++. So this is all about JVM architecture. Thank you.